Thanks for coming to this session. We're very excited to be here. So let's see. Oh, there it is. So for these guys, I'm Eugene. I work for Lightbend tooling team. I'm a tech lead there. And
I'm Dale, and I work with Eugene on the Lightbend tooling team.
Yep. So one of our main responsibilities for tooling team is maintenance of the SBT. So that's basically what we're going to talk about today. So each conference I go to, I keep adding more slides. So there's going to be fresh material, even if you may have seen part of this talk. But it also means that I probably have to go faster so I can cover all these different materials. So it's a little close. Okay, so first, I just added 2 minutes ago. I just want to talk about it because it's not covered in any other part of the talk, is that there is SBT by example. This is a one-page tutorial that goes from 0 to making Docker container and running application inside. So if someone is new to SBT, I'm not sure if any of you guys are new to SBT, but if you know someone who's new to SBT, this might be a kind of interesting entry point into learning what SBT can do. It doesn't really explain what it does, but it just kind of goes through these examples. So check out this stuff. So today I want to talk about sort of what SBT1 is compared to the 013 basically. And the concept I want to talk about is the overall. So I'm not sure how many of you have been to Japan before and Kyoto. So if you go to Kyoto, oftentimes you see the shrines and temples under construction sometimes, and the other times it's not. So the idea is that the country is basically 1,500 years old or something like that, and these temples are hundreds of years old, and it's always raining, and these things are made of wood, right? So what do you do is that parts get old or rotten and things like that, and actually people who maintain it, they kind of forget how to put these things together. So every 30 years or 40 years or whatever these generations, they actually take this whole thing apart and then put it back together. And if you see parts that's not good, then you kind of substitute them. And in a way, you can think of our organisms to be like that. We have these cells, and then when cells go bad, you just kill them off, and then you replace it with the new cells. Or you can think of it like microservices like that. So that's the process of basically overhauling. And the SBT1 essentially is that process applied to 013. So we basically chop them up into different modules, and parts that are kind of getting old, we replaced it with the new ones. But the overall goal of SBT, so the overhauling, right? So you remove the old parts, you update some of the new parts, and along with it, so I'm not the original author of SBT, actually, neither is Dale. There is another person, Mark Haraf, who created it. So we're the current maintainers. So along these process, we're also relearning how to put these temples back together. And it's actually good for the community to actually know how to build back the SBT. And the goal of SBT1 is to not basically break your ecosystem. And so the feel of the SBT1 should be really, really similar to SBT 013 with just some of the parts updated. That's basically the goal. So I'm going to kind of quickly go into some of the parts. So first, this is not exactly a part thing, but it comes up frequently, is that SBT1 is semantically versioned. So there is SBT 115 that was recently released. So throughout 1.y.z series, it will be binary compatible, similar to the way 013 was compatible through 013, 1, 2, 3, all the way to 17 or something like that. So once you release a plugin against 1.0 something, that would work against 1.1 and 1.2. Right, and so there is a feature release, which is 1.1, and then there's patch releases like 1.1.2 and 1.1.5. Another thing is that instead of using a IB layout repositories, that's using Bentray and redirects and stuff like that, SBT1 is now just published into Maven Central, just like any other libraries. As some of you probably know if you've used it, so 013 series was using SBT 2.10. That's really, really old now, and basically it's like EOL'd. And SBT 1 obviously uses the latest stable one, which is 212. The part that's a little like, I think this is probably the most that you might come across as a very different part, is that the in order to keep binary compatibilities, we no longer use case classes. We actually use a pseudo case class, is what I call. It's essentially a generated code that looks like a case class, but instead of copy, we use with. So this allows us to essentially add a new field without breaking the binary compatibility, because copy basically and unapply is really difficult. It's basically impossible to keep binary compatibility if you have like unapply and copy. And conveniently, it also generates the JSON codec for us. If you've been to the talk earlier, there was talk about zincwan. So as part of the process, not just I think of myself sort of as a tooling team person, not just the SBT person. And for sort of like a sake of the tooling community, one of the goal was to basically allow the different build tools or experiment to basically reuse Zinc. So previously, the incremental compiler was part of the SBT codebase, but we basically split it up and put it into different repository. And the ownership of this repository is actually co-maintained between the Lightband, who's the original author of this incremental compiler, and the Scala Center. And anyone who wants to join in can now directly contribute to the incremental compiler part of the SBT, the Zinc. And it uses this new algorithm called class-based name hashing, which is supposed to work for a larger code base. So that's another updated part. Hold on, there it is. So another thing that we wanted to abstract out as another module, is the LM or the library management. So one of the popular sort of the thing that we hear is that the IV is really slow, and then there is the Corsair, right? So we knew that going into SBT1, but we weren't really sure if you can make this jump immediately. So the thing I did in the LM is to create essentially the abstraction layer so that there is zero reference to Ivy itself in SBT1. There is now essentially a trait that abstracts the concept of the generation. So later on, we can now add the second implementation of the LM API that is now kind of ongoing effort. That will basically use Corsair as a backend, but you can basically be able to switch back and forth using this LM API. The stuff that got removed in the sort of like the parts that no longer are used in this SBT1 world is SBT.plugin. I'm not sure if any of you guys use the different plugins, but basically maybe 3-4 years ago, there's 0.13.5 that came up with the SBT auto plugin. So that's now the main one. So we no longer really need SBT.plugin. So that's what was removed. Another part that was removed is the essentially SBT 0.12 style of the DSLs. That includes this key dependency operators, popularly known as the fishbone operators. Tuple enrichments, these are removed, as well as the SBT.build trait. So that's the build.scala style of writing build that was removed. And then basically we just now consolidated to using build.sbt as the only way of being able to write your build.
And this was a feature that we introduced in 0.13 and eventually it was stabilized. And so with the major version release, we could remove the old syntax.
The new parts, we're going to probably talk about these later in the separate section, but SBT server, unified /syntax, these are kind of like the new parts that were added. But basically the general feel of the SBT shouldn't have really changed, basically. So we talk a lot about like an ecosystem. So next section, we'll kind of explore what SBT ecosystem basically is. So one concept I think about is SBT itself is sort of like a hub, right? So there's a SBT itself represents a bunch of builds that you guys build. And the SBT itself, like a single build, knows about your dependency graph, and it also is able to basically harness the library ecosystem. For example, the 210 or 211 naming convention that was basically created by SBT, which now we can use that to basically keep the binary compatibility and cross-building. So before that existed, like different versions of Akka would have different dependency of the Scala, right? So we weren't able to do the cross-building. Test interface is another example where SBT created the test interface. So specs and Scala check and Scala test can basically use the same interface. So when you type test into SBT, you don't really have to think about different implementation of the test frameworks. The other things are like development tasks. So you can basically use SBT as like a shell where you might want to deploy Docker or do different things specific to your company's workflow. You can customize that. And then there's like a whole bunch of plugins we have. And as well, I think SBT is a community of different developers, both in terms of the users and as well as the contributors. So how exactly big is this ecosystem, right? It's kind of like difficult to kind of figure out just by looking at the public numbers. But here are some of the hints, basically. So in GitHub, I typed in Scala version with the extension of SBT, thinking that if you have built an SBT file, you can maybe be able to find these things. And that's like 147,000 code results. So that's kind of like what's on public. In terms of the download numbers, these are like even more murkier because there's automatic tools and stuff like that. But so SBT1 is hosted on Maven Central, right? So I'm just looking at the SBT1's adoption curve. And last month, it was around 209,000 download. And a week ago, we released SBT 115, right? And that installer download number was around 12,000 as of this morning. So basically, these are basically the numbers. What we're thinking about is these bunch of users. So the reason why these are kind of important is that even though there are basically things that you can try to rebuild on other build tools or something like that, what I kind of keep in mind is basically even if you can make like a small increments into SBT, that can affect like a whole bunch of the existing build users that can like improve their productivity or lives. Another big thing about the ecosystem is the plugins. It's a really great way of enhancing your the native packager. Is Mookie's and Josh's plugin that can really enhance the capability of the build tool itself. By adding like 2 lines in your build, you can turn your app into a Docker container and do all these cool things.
So I just wanted to. So this is like the plugins for us is a huge part of the ecosystem, and it's something that we care very much about, and it's why we make so many references to binary compatibility, because these plugins use SBT as a library. They extend the behavior of SBT, and so they integrate in a sort of programmatic way with SBT, and they provide so much value to the SBT community. And so we're very tentative and careful in making sure that when we make changes to SBT and make fixes, that we don't break these plugins, so that the maintainers for these plugins can continue to safely release new versions or introduce new plugins. And so that just wanted to sort of explain why binary compatibility is so important, because we have this large period of time where we commit to our API and people can safely introduce new plugins, or in this case, it was about porting the plugins from 0.13 to SBT1.
Yeah, so this also kind of shows how SBT1's uptake is pretty good, because out of 341 013 plugins, according to the Scala Decks, basically 200 of them have basically migrated already, and I'm guessing those are the top most popular 200. And here's one of the, what we were doing sort of behind the stage. I'm not sure if it's complete behind the stage because we're tweeting and stuff. Is that we use the GitHub star as a metrics to find out how popular the plugins are, and then created this like a wiki page basically that has a number of like the stars and the status, and then tweeted this out and asked people to jump in and help migrate the 013 plugins into SBT1. So within 10 days, we also had there's in progress, released. So, like in maybe there was a 50 plugins within a couple of weeks. And I think in 3-4 months or something, there was 100 plugins now. And these are basically the top ones that we cared about. And then the Scala decks also show that there was a whole bunch of other that happened afterwards as well. So these are basically community efforts that we're doing. So it's not just us. We encourage people to do these, but a lot of these are done by the community efforts to migrate this ecosystem. So do you want to talk about these? Yeah.
So I wanted to kind of to an audience that we might not be able to reach often, sort of give more understanding of SBT as a project as opposed to as a product. And the sentiment here is very much to explain how we stick to as much as we can to the way things are done in other projects, other open source projects. So we use Gitter, for example, to communicate, and we have what seems to be a usual split between talking to the users and having a dedicated channel for contributors to talk about internal changes and within that community of contributors. We have weekly meetings that Eugene and I use to coordinate things, and we try and we invite contributors, people interested to make changes to SBT, to join us every Wednesday to talk about maybe ideas they have. Maybe they have something they want to do in terms of changing SBT. We have a discourse channel from Lightbend where we talk to tooling in general, and SBT is obviously a part of that. We use a tag on Stack Overflow. Eugene and I both try our best to try and help people there, along with on Gitter. We use GitHub, and we have a Twitter account. So this is just, again, as I say, ways to show you how this is just a software project like many others. And do you want to switch? And so, as Eugene mentioned at the beginning, in SBT1, we started to break down SBT into sort of the subsystems that compose SBT. So Zinc has been referenced, library management. There's a couple of smaller ones, util and IO. And there's a few additional ones on the side that I just wanted to mention because they are relevant at some, within SBT's development. So just a couple of names on the slide of the part, like the website, for example, is a standalone repository where we have documentation and release notes, and recently the examples page to help users learn about how to use SBT. And as many other Scala projects out there, we use SBT ourselves. We use Travis CI for validation. And we test things with the test tools that exist in the Scala ecosystem. So if you do look at contributing in SBT, you'll find that we use SBT and that we test with Scala Test or Specs 2 and so forth. So that's, as I said, the sentiment here is that it's very similar to other projects. And there are many ways you can contribute. Like I mentioned a bunch of things about the code and how it's tested and so forth, but you can also help in many other ways. Being present on the Gitter channel or on Stack Overflow and helping other users, for us, is helping contribute to the project. Documentation fixes, as is often referenced, is a great way to help. As Eugene and I, as Eugene said, we're often learning how SBT works. But at this point, we've learned a lot. We've learned a bit too much about SBT, so it's hard for us to explain SBT in a way that, by removing with parts that we really understand ourselves. So external people helping with that improves the project. And of course, reporting issues, helping grow the plugin ecosystem as distinct domain and sort of niche domains get addressed is helping SBT be successful. And ultimately, patching the core is what's usually referred to as a contribution. A few examples of how. Do you want to jump in?
Sure. Yeah. So this is kind of like a more newer way of thinking about contributions, but the issue tracker is like one of these, like a living thing. So one of the great ways to contribute, actually, if you don't really have time to like code and stuff, but is just kind of like getting attention to us. So sometimes like we're just like bogged down in like some like whatever tasks, but there could be kind of interesting discussion that's happening in the issue. So if you want to like get the attention of us in some channel saying, hey, there's like a really interesting issue that's being reported, but like we weren't paying attention for like a couple of months or something like that, right? So one of the ways to contribute might be just like getting our attention somehow that there is an issue, or try to like reproduce it and get more data into trackers. Or one of the things we started doing, there was a hackathon yesterday, right? And it was like a really interesting experience just talking to a bunch of contributors and then seeing them trying to set up. So to set this up, one of the things we did is like a tag some of the stuff that's help wanted or good first issues, and just put the link into here's the likely source code that you need to fix this particular bug. And we can do that pretty quickly. So if someone wants to ask, hey, like I want to fix this issue, like where do you typically start with this particular code, we can usually tell you in 10 minutes or or whatever. So these are kind of like interesting like ways of contributing, is to kind of like go into the GitHub issues and then kind of like do the gardening basically. So patching the core, that's the actual coding part. One thing that we encourage is to, if you have ideas, try to open the Lightbend Discuss forum instead of spending too much time. Like we encourage coding, but it would suck if you spend like your whole weekend and then like there goes in debates like and shut the whole thing down, right? Like if you're doing it in like some ways that the community people didn't like or something like that. So we encourage like a discussion first, sort of, and then once the people are kind of settled into how things should work, and then you can kind of like spend time more coding. So that's kind of like the one thing. The other thing that it's not here, but we discussed a lot recently, this idea of the optimistic merging, where instead of like going too much detail into the code reviews, we basically take your pull request and then just like massage it ourselves if we don't like, oh, you're using arrays versus vector versus this and that, right? It's just easier if we just take your code and like fix it ourselves or something. So that's something that we might try to do. And it usually works well. Like we do that to each other sometimes, like you'll fork his code and he forks my code and back and forth, so.
Yeah. So one of the strengths in SBT as well is we have a plugin ecosystem which allows things to be explored within a plugin ecosystem. If it's a niche domain, then it can be born as a plugin and stay as a plugin. But sometimes, and there is history for this, where some part of SBT doesn't quite work the way you want it to work, and the lovely thing about SBT is that you can explore an idea as a separate plugin without requiring to modify the core, and at that point you're no longer bound to the release cadence of SBT, to sort of merging into SBT and integrating. You can just iterate independently, and actually this modifying the way that SBT works can even start earlier than a plugin. You can, within your build, you have full flexibility because it's defined in Scala to define behavior within the build. You can then eventually, like step 2 might be to extract that and generalize it away from your specific project and your specific build. So that will be a local plugin. And then you might find that works really well, and you want to use it in multiple builds, and you can extract it in a standalone plugin. And then these are examples here of things that were experimented with and iterated on, and to the point where they were better than the way SBT worked. So Doge is maybe one that's known a bit better, where one of the things that SBT did is it has support for multiple Scala versions, but sometimes within a build where you have multiple projects, not all projects use the same set of Scala versions. And so the support that SBT had for doing things across multiple Scala versions didn't handle that different projects had different sets of versions. So Doge was Eugene's experiment to look at how this could be done better, how support for variant Scala versions could be fixed in SBT, and eventually the whole community basically used it, and it was better than the way core worked, and we rolled it in. And Slash is a similar story where we had this. Well, Eugene had this idea of I think we talk later about Slash, but about this difference in syntax, and we explored it in Eugene explored it in a plugin, and it looked great, it worked great, and we brought it in and we shipped it in SBT itself.
So one of the things that's kind of unique about SBT potentially is that like compile tasks and test tasks and like something that you are probably used to, they're actually implemented as a plugin itself. So you can a lot of times swap out these implementation that's already in SBT in a really flexible way. So that's one of the reasons you're able to basically write another plugin that replaces its behavior. So server this is a brand new feature of SBT. So there's been some mention about LSB. So I just want to kind of quickly mention this is the created by Microsoft originally for the VS Code. VS Code is this editor like Visual Studio Code. And the idea is that the traditional, like Eclipse and IntelliJ and all these IDEs like Visual Studio, they're kind of hard coded to one language, right? So only like the huge vendors with like a lot of budget can, create like this great IDE, and then kind of like gradually that like language or the IDE kind of loses popularity, and then like it kind of dies or something. So instead of doing this, what Microsoft did with the VS Code is that they realized that there's a whole bunch of languages that's happening, and they couldn't do this on their own. So they created this like a protocol called LSP, Language Server Protocol, where you basically make this like a node web server like abstraction of the IDE features, like go to definition or just type compile. And people realize that, this is just like a protocol. We can do this ourselves to like Sublime and Eclipse Che and the NeoBim. They all kind of act as the LSP client. In the back end, people can like implement Python and all these different things. And actually SBT server kind of like works sort of as the LSP server. So you can point VS Code against it, and then you can just kind of like do your thing. I can actually show you this now about the, let's see if this works. Can you guys see from all the way in the back? Okay. So I opened the VS Code, and there is actually like a plugin for this. And object, hello. So I'm just gonna make an error, try to make an error. So that's how long it took to get the red squigglies, basically, right? Like, and because it's zoomed out, I have to kind of go here, and this shows the location of the error message, basically, right? So this is just basically running SBT inside of this like a tab here. So you can also get like normal stuff like name or something, right? And then say foo, and all you do is like command S, save, and then it compiles, right? So basically kind of like replacing tilde kind of thing, but just with like a saving function. So it's kind of like a classic Eclipse kind of thing where you hit save and then it compiles, and then you get the error message like this. So yeah. So that's the VS Code. This is sort of like a low-tech LSP server. Scala Center and other guys are making even better ones. So hopefully soon we'll have like even better one that has like the indexing and all these different things. But this kind of goes to show that the one of the goal of the SBT server basically is more about integrations. So the SBT, like I was saying, it's like a hub of incremental compiler and like your dependency graph. But there's just all these need for like more like a richer experience, right? Like being able to jump to errors and code navigation and things like that. And LSP and event logging kind of sits right in the middle, basically. I'm gonna skip the history of SBT server. Basically, the activator sort of like you can see it as like a kind of like a nascent direction towards that stuff. And I basically showed this stuff already. But one of the kind of like interesting experiments toward, like a direction of like being able to use the server is, like I said, the IDE integration is one. Another potential is basically be able to distribute these build once you're able to basically talk to another machine and like cooperate the build together and stuff like that. But these are basically some of the ideas that can potentially be used. Okay. So event logging. All right, so let's talk about unified syntax. I think these are more fun. So build, right? So in 013, there was basically two notations for build, right? So there's one build description, which is what you write inside of the build.sbt, and then there's a whole another language within the interactive shell. If you want to do something more complex, like I want to run the, this subproject's test configuration compilation or something like that. You have to know like slash and colons and double colons and all these different things. And it always kind of like annoyed me that you have this like two different notation for exactly same thing. So that's kind of like example of that, right? So you say like Scala options in test console.value. You do that in shell using colons and double colons. So SBT11X, they're the same thing. You just use slash for everything. So the unification basically is slash. You say reference, that refers to basically either this build or name of your subproject. And you write the configuration in all uppercase, and the key will be in the lowercase. So if you want, like, basically what you typically write in the build.sbt, it basically works both ways. So foo test uppercase t test slash compile, basically, you can figure it out. It's like test, configuration compile.
And this was partially aided by the work that we'd already done in SBT 013 of transitioning keys, so task keys and setting keys from kebab case, what it's called, where the dash is in the middle, to camel case. So some of this had already been started in 013, where there was a difference between the code, the configuration stage of SBT and the runtime of SBT when you're interacting with SBT in the shell. So we transitioned most things, and a lot of the plugins transitioned as well to using camel case. But the rest of the syntax had the original shell syntax, and so this difference was jarring. It was an unnecessary learning curve of SBT to have two versions, and there were reasons why each had developed in the direction they had. Thankfully, we were able to explore, as I said earlier, in a separate plugin, an alternative syntax that unified the interests of both of them, and this is what it is. And as Eugene says, it's as of 1.10, it's available now.
Who do you think this is better than 013? I just want to kind of like get the feel of you guys. Or who thinks the 013 style was better? You like typing double colons? Okay. So I don't want to go too much into the scope delegation. It's a complicated stuff, but the this ordering actually does matter. So when you type something like foo test console, there are basically places that SBT looks for that, the existing stuff. So, in case you don't have foo test console Scala options defined, these are the ordering basically of the places that it's going to look for. So if you have it in like a compile console Scala options, it's going to look for that. So this if you can remember this ordering, this kind of like intuitively sort of tells you the scoping ordering as well. All right, so I'm going to quickly talk about time. There's a movie called About Time, which is kind of fun. Like I like to think about these like time traveling stuff. So there's this paper, I think, that came out in like 1979 or something, called Time Clocks and the Ordering of Events. And this actually kind of does matter to SBT. So if you're time traveling, there's like, you have to kind of think about different things. And this is how you kind of describe how you time travel, right? If suppose you're a time traveler. So this is a space-time diagram to describe your kind of like your journey. And by sort of the, relativity, there is no such thing as clock once you have time travel, right? Because the moment I tell you what time it is, it's already happened in the past. So there's really no way to synchronize clock between you and I, right? So, but you can kind of tell each other what has happened already in the past. So that's basically what time is. And there is no such thing as a clock, but there are events. And what this is kind of showing that so Lamport has invented this great thing called Lamport's arrow, where this arrow means it happened before. So event A has happened before event B, right? So if it's within this same process, that's what this arrow means. And in case that there's two different processes or cores or whatever you want to think about, it means that happened before actually means that like you told me about it, right? So that's basically message passing. And so A arrow B means A happened before B. And you have this like slash, that means that A did not happen before B, right? These are okay, right? What's interesting is that if event A and event B has mutually like a didn't happen relationship, that's the definition of concurrent, right? Do you see? Maybe people are a little confused, but so, like these, I don't know, like it's sunny today and someone is wearing black or something like that, right? They didn't happen with any sort of correlation, right? Someone is wearing black shirt and it's sunny today. There is no, happened before relationship, therefore they are concurrent. So concurrency has more to do with the causal effect than the actual parallelism, right? So, but the interesting effect is that because they don't have causality, you can basically parallelize that. And that's why in this case, P3 and Q3 is concurrent, right? And this sort of shows that in the event of time space, you can kind of reorder things without affecting the causality and like break everything in the world. And why does this matter? Is in functional programming, this is expressed as an applicative functor. There was a talk today called they call it monoidal functor, but essentially you put like 2 and 3 into like a box and then you take it out and then you put it back in. So in a way, like the task or the setting graph is essentially using the applicative functor. And if you think about this, essentially SBT, so there's a do notation in Haskell that encodes a flat mapping, right? Like a monad thing. And this is really like nicer, I think, than the Scala because, it's really kind of tells you, like it's almost like it's a real code, right? Like there is no for and curly brace and something like that. There's like it happens this and it happens that. And in a way, I think SBT's build is essentially like the do notation for the applicative, right? So in the procedural code, there is happened before for each line, right? Like val x get line, print len, and then get line again, and x and y. So there is this like implicit like happened before relationship within your procedural code. But SBT is not like that. And that's why I'm mentioning this right now, is that in SBT, dot value is not a function call. It's actually a denotation saying that compile is happened before foo. And bar has happened before foo. So by the time this beginning curly braces reaches you, these two tasks has already happened before. So it looks like this, right? This is still the lamp ports happened before. So compile has happened before foo. And that's what this build DSL basically encodes. So that's kind of like the most difficult part about SBT. You kind of have to grasp to really understand this. And this tradition goes all the way back to like make and, you know, the ant. They all do these things. Basically, you're describing your task based on the dependency of someone else. And then you're kind of building up this graph. But the way we express it functionally is using this applicative. So that's the line of sand in the time space. And these can be run both in terms of the real meaning of the concurrency as well as in parallel physically. So that's all I have for today. Thank you.